All right, so we are going to go ahead and talk about nonlinear two-variable solutions. Remember that when you are doing these for me on a test, I want both an algebraic solution and a graphical solution. So we're going to go ahead and start with this first one, which is x plus y squared is equal to 5. And then the second equation would be x plus 1 was equal to 1. All right, this first equation, equation 1 is a circle. Equation 2 is a line. When you're solving these, the best way to solve these is to pick one of the equations and use substitution into the other. So what I'm going to do here is I'm going to solve equation 2 for y. So x plus 1 is equal, y is equal to 1, y is equal to negative x plus 1. Now, what we're going to do here is we're going to use substitution. And we're going to take, because y is equal to all of x plus 1, I'm going to take that negative x plus 1 and substitute it back in here. Make sure you put parentheses around that y squared when we plug it in. And again, this is called substitution. It is the best way, and pretty much sometimes the only way, to solve nonlinear systems. All right, so what I have when I plug that back in is I go ahead and get x plus negative x plus 1 quantity squared is equal to 5. So I have x squared plus negative x plus 1 times negative x plus 1 is equal to 5. Make sure you remember to FOIL that out. When you go through and FOIL that out, don't let the negatives bother you. It's just x squared that becomes a negative x times a negative x. So it's still going to give me a positive x squared. Then I have a minus x times negative x plus 1 is equal to 5, which gives me 2x squared minus 2x. Minus 4 is equal to 0. If I go through and divide everything through by 2 here, again, if you're using this technique, you can only use it when you have an equation. Make sure you divide everything by that. I'm left with x squared minus x minus 2 is equal to 0. I have to factor to solve this. Now, the interesting case about these is we do have two solutions. So let's go through and factor this. The only two factors of x squared are x and x. Only two factors of 2 are 2 and 1. And because you want that to be a negative 1, that needs to be a negative 2 and a positive x. So I have two solutions here. I have x is equal to 2. We'll go ahead and call that x1. And then my second solution here, x2 is equal to negative 1. And that's because when you have this kind of system, you have the possibility of having multiple solutions for the same system. And we're going to show what that looks like in a graph on the next slide. So, and then the second piece would be x2 comma y2. Oops. Let's fix this and turn that back into x2 the first. So what I need to do here is I need to find these points. So this first point, x is 2. I have to find my matching y value. And in the second point, my x is negative 1, and I have to find the matching y value. Now, just for the sake of simplicity, I'm going to plug it back into the equation. Y is equal to negative x plus 1. Just make sure that you keep these points organized, and when you plug that in, that becomes negative 2 plus 1, or my y value here for 2 matches a -1. That's my first solution. Remember to always write these as points. And again, going back to y is equal to -x plus 1. For this one, now it's negative times a -1 plus 1, so my y value here is 2. So those are the two different solutions that I have. Again, you must write your answers as a point. Now we're going to go ahead and go on and graph this. All right, so going back to what we had before, our two graphs are x squared plus y squared is equal to 5. This is the equation of the circle, which is in the form x minus h quantity squared plus y minus k quantity squared is equal to the r squared. In this case, h, and in all cases, h and k is the center of the circle, and r is equal to the radius. Now, because there is no plus or minus here, what this means is that my center of the circle is at 0, 0, and my r squared is equal to 5. So r is equal to the square root of 5, which is approximately 2.2. So I'm going to come out here a little bit more on each section of this graph, a little bit more than 2, and go through and draw in my circle. All right, so now we're going to go ahead and do the line next. The line that I had graphed there was y was equal to x negative x plus 1. What that means is, let me just go ahead and draw this back in here. So that means right about here at 1 was my y-intercept. I want to go down 1 and over 1 and draw this line in. And let's look to see what I have here. Where do these 2 points meet? They meet right here at 2, -1. That was one of my solutions. And the other one of the solutions I have would be meeting up here. And that point here was at -1 and 2. So that's the graphical solution for this. All right, so this second example I'm going to do for you is a y is equal to x squared plus 1. This is equation 1 this time, and this is going to give me a parabola when I graph this. And the second one again is equation 2, and that is the graph of my line. So we're going to go ahead and first do the algebraic solution. Remember, you must show both of these to get credit. So algebraic solution primarily with this uses substitution. So I'm going to go with this, and I have, all right, so we could have done this the other way we've done last time, but I'm going to show you something a little bit different. So if you notice with this equation is already solved for y, right? Y is equal to x squared plus 1. So I'm going to take all of that and plug it in right in there for y. So this was x minus y is equal to 1. But again, I'm not going to use the y from the equation of the line. I'm going to go back up, and because I know that y is equal to that x squared plus 1, I'm going to go ahead and just put that in. That's x squared plus 1. So let's go ahead and take a look at this. What I have is x minus x squared minus 1 is equal to 1. I go ahead and put that in descending order, and I get negative x squared plus x minus 1 is equal to 0. I needed to take this and subtract 1 from both sides so the equation could equal 0. I have to do this because this is a quadratic, and in order to be able to solve a quadratic equation, I have to have it factored. Now, that leaves me with negative x squared plus x minus 2 is equal to 0. If I multiply everything through here by a -1, I will end up with x squared minus x plus 2 is equal to 0. Now this equation is not factorable. I need to use the quadratic equation. So I need to go through and solve that for x is equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, when I'm using the quadratic equation, you just go through and label everything. A is equal to 1, b is equal to -1, and c is equal to 2. I plug that in for my quadratic equation, and I get x is equal to negative of the negative b plus or minus b squared minus 4 times a times c, all divided by 2 times a. Now, when I do that, what I see is I get a 1 plus or minus the square root. Now, underneath here, remember to go through and do the order of operations. This is going to equal 1 minus 8. You have to do all of this together before you subtract it, which gives you a -7 underneath the radical, all divided by 2. Now, this is important because what this is an imaginary solution. That gives us I. That tells us there are no solutions to this system. And just because there's no solutions doesn't mean you don't have to graph it. We are still going to graph this. All right, so when I have this, we're going to first go through and graph our y is equal to x squared plus 1. That is our parabola. That parabola has gone up 1 and still has the same shape of the parent function that looks like this. My line in this case is y is equal to y is equal to -x plus 1, or y is equal to, that now becomes a positive x minus 1. So my y-intercept down here is at -1, and my slope is 1, so I go up 1 and over 1. And what you see, and this is the reason why this has no solutions, there's nowhere where the parabola and the line meet, hence the imaginary solutions. All right, we have one more to do, and this one does not have an algebraic solution. That is within the realm of what we can do, but it is an interesting case, and I want to make sure I go over it. If I have the graph y is equal to e to the x, that is our exponential function that we've talked about before. We know when we have this that one of the main points that I have on this graph is 0, 1. And that's an exponential function going up. So the parent function of this looks like here. Now, the next piece I have inside this graph is the graph x plus y is equal to 1. Now, solving that for y, I get y is equal to -x plus 1. That idea of that y-intercept is the same. It's in exactly the same spot. My slope is -1, I go down 1 and over 1. So this graph is only being able to solved by the graph, and the only point that they have in common is that one point right there. So the only solution for this would be 0, 1.